Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello teacher, hello students. Welcome to today's lesson, which begins our unit on vectors in space. Today, we will be examining the key characteristics of vectors in space, as well as doing some addition and subtraction of vectors in space. Please have a paper and pencil ready, as we will need to draw a few graphs to examine our key concepts, as well as resolve the examples we will be working on today. Let us first review some of the characteristics of a vector on a plane. Vector quantity, both magnitude and direction. A quantity that only has magnitude but no direction is referred to as a scalar quantity. A vector quantity is represented on a plane by an arrow, like the one in the graph presented here. We can determine the magnitude of the vector by the length of the arrow in the graph and the direction of this vector by looking at which way the arrowhead is pointed. The standard unit we use to identify vectors are I for the x-axis, J for the y-axis, and K for the z-axis. This will allow us to determine the coordinates of any vector's initial and terminal point in space. We can represent any vector in terms of unit vectors as demonstrated here. For this demonstration, we will rename vector OP as A. So, we may simplify our equation to vector A equals xi plus yj. If vector A equals 6i plus 9j and B vector equals 12i plus 10 J. What is A vector plus B vector? What is A vector minus B vector? Take a few minutes to calculate the answers.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. The terminal points of vector A and B, respectively, are at coordinates 6 9, and 12, 10. The terminal point of vector A plus vector B is 18, 19. This can be found by adding the corresponding coordinates of the terminal points of both. This is expressed as follows. If your answers are the same as they appear here, you have found the right coordinates. Excellent work! Just like vectors on the x-y plane, we can add or subtract vectors in space using the coordinates of terminal points when their initial points are at the origin. This means if A and B are vectors in space with their initial points at the origin and their terminal points at x1, y1, and z1, and x2, y2, and z2, respectively. Then we can conclude that vector A plus vector B is the vector with its initial point at the origin and terminal point at x1 plus x2, y1 plus y2, and z1 plus z2. Therefore, the sum of two vectors is obtained by adding the corresponding coordinates of the terminal points of the two vectors. Students, do you think you can apply these concepts yourselves? Let us practice this now with an activity.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. If you have been following up until now, then the answer should be easy to find. When graphing your answer, you probably arrived at a similar image to what you see on screen. The three components are the vectors with the common initial point O at 0, 0, 0 and terminal points A at 14, 0, 0 on the x-axis, B at 0, 8, 0 on the y-axis, and C at 0, 0, 5 on the z-axis. Thus, vector OP equals vector OA plus vector OB plus vector OC. The coordinates 14, 8, 5 equals 14I plus 8J plus 5K equals 14, 0, 0 plus 0, 8, 0 plus 0, 0, 5. Let us examine this next problem together. If vector A has the coordinates 1, 3, 2, and vector B has the coordinates 3, -1, 4, how do we find the sum of vector A plus vector B? Since the sum of two vectors is obtained by adding the corresponding coordinates of the two vectors, we can derive that vector A plus vector B is equal to the coordinates 1, 3, 2 plus 3 -1, 4. This equals the coordinates 4, 2, 6. Students, today we have started our study of vectors in space by examining some of the characteristics of vectors. We also practiced our ability to add and subtract vectors in space in order to uncover their origin and terminal points. In our next lesson, we will be looking at the multiplication of vectors by a scalar point. Until then, thank you, teacher. Thank you, students.